Hello, this is Mr. Stansbury. I'm going to take you through the notes on series. At the end of this, you should be able to say, I can use sigma notation to find the sum of a series given several terms and vice versa. Okay, so first things first. A series is the sum of the terms in a sequence. So we're going to take all the terms of a sequence, add them all up, and get a total. Okay, a finite series has a first and a last term and will therefore always be some kind of finite real number. So like, for example, if the series was 3, 7, 11, 15, and 19, this is going to give us an actual finite number. Okay, an infinite sequence has a beginning but no end. So like 3, 7, 11, 15, 19, dot, 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 meaning it goes on forever and ever. In many cases, the sum of an infinite sequence cannot be calculated, but in some cases, it does actually converge. It ends up getting closer and closer to a finite number. Okay, so we'll look at some cases like that. All right, the sum of terms, u sub 1, first term, u sub 2, second term, u sub 3, so forth and so on, all the way up to u sub n, which u sub n in this case is the last term, can be written using sigma notation or summation notation. This symbol here, this little funny looking E, is sigma, okay? And that's why it's called sigma notation. Okay. We write u1 plus u2 plus u3, so forth and so on, all the way up to un as this here. We got our little sigma notation here, k equals 1 on the bottom and n on the top. And then we've got our u sub k out here. Okay, so this reads as the sum of all numbers of the form u sub k, where k equals 1, 2, 3, all the way up to whatever n ends up being. Okay, so that n is going to be the last term in the sequence. All right, for example, here's our little sigma notation. The k is our index of summation, it's called, and that equals 1. So 1 is going to be the first value of n. So when we go through and figure this the series out, then what we would do is we plug in 1 for n first, and then we plug in 2, 3, 4, 5, all the way up, and our last term is going to be 7, the last value of n. Okay? So if we were going to do this here, this is going to look like this. Plug 1 in for n, and that's going to be, let's see here, that's going to be 3, right? And then we're going to plug 2 in, and again, we're going to add these all together. So instead of putting a comma, I'm going to put plus. So then we put a 2 in. 3 times 2 is 6. That's the second term. So we even do this first, second, third. So the next number is 9. We're keep multiplying by 3. And then 12, 15. So that's the fourth, fifth. And then 18, sixth. And then 21 is going to be the last one. So this all here is saying, what does this all equal? Okay? Okay. Let's take a look at example 22 here. Consider the sequence 2, 5, 10, 17, dot, dot, dot. Okay? Write down an expression for S of n. Okay, so what we really want to do is we want to come up with what's our u sub n, what's our formula for this here. Okay, so what we just did is we figured out that this is the term squared. So like 1 is the first term, 1 squared, and then you add 1. Second term, 2 squared, and add 1. Okay, so we figured out how this sequence works. All right, so what we can do is say, okay, we can start with our little sigma notation here. It's supposed to have these little feet on the end here. So we are going to have our k equals 1, okay? And then our formula we figured out is going to be our k, or whatever our term number is there. It's going to be k squared, and then we're going to just add 1. So we're going to add 1 to each term, right? Okay? And then in this case here, we don't know where it stops. It keeps going on forever and ever, so our last term is going to be n. Okay, so this is our expression for S of n. Okay, so again, this means starting with 1, going up to whatever n ends up being, which we don't know because it goes on forever and ever. Basically just trying to figure out how do we figure out what each term is. So again, some of them you're going to have to do, you're going to have to, kind of look at and try to figure out what the heck's going on. Some of them will be easier, some of them will be a little bit more difficult, but just keep working at it. If I've found that if it's going up by a different number each time, it's usually going to have some kind of like square in there, and that usually, if you start with that, if you've got adding by a different number each time, then that will usually help you figure out what's going on in that. Okay. Anyway, find S of n for n equals 1, 2, 3, 4, and 5. So what we've got is we've got S of 1. So the first term, we put a 1 in there. We already know what that is. That's just 2, right? So the sum of just 1, the first term, is 2, because that's the only one we have. S of 2 is going to be the first term plus the second term. So that's going to be 2 plus 5. And that's going to give us 7. Okay. S of 3, 2 plus 5 plus 10 is going to be 17. S of 4, our fourth term is going to be 2 plus 5 plus 10 plus 17 is going to be 34. And then S of 5, 2 plus 5 plus 10 plus 17. We don't know the fifth term, but we can figure it out, right? Because we can plug 5 in. 5 squared is 25 plus 1 is plus 26. So really we're just adding on this 26 to the 34, right? Which gives us 60. Okay? All right. Okay, that's all we have for this section. If you have any further questions, please feel free to ask. Thanks.